Hello and welcome to XC Psychology. This is the first episode of a brand new series called The Foundation of Physics and Chemistry for Life, where we're going to dive into areas mostly related to neurobiology and neuroscience. Now, today, we're going to try to answer the question, what is everything made of? The answer is matter. And just to be very cheeky and cliche about it, you matter and your feelings matter. And I hope you remember that always. So what is matter? When I'm diving into this question, I actually wrote a poem about it. Here it goes. Everything begins with matter. The air you breathe, the rain you embrace, the cat you kiss, the thoughts you can't replace, the coffee you taste, even the grandma is here, even the grandma you miss, they are all made of matter. And matter has mass, and matter takes up space. That's the definition of matter. It has mass, and it takes up space. So now let's have a look at the concept map inside an atom. And so we've talked about matter. Matter is basically things, objects, stuff that make up other things like coffee and tennis balls and cats and grandma. And matter is actually made of atom. An atom contains nucleus and electrons. A nucleus further contains protons and neutrons. And I know this is just a concept map for relationships. We'll have a look at an atom now. So here is an atom, and it has all of the things we've discussed before with a little bit more details. You can see that here is our nucleus, and it's basically a dense center containing the protons and neutrons. And we have our electrons kind of just floating around the nucleus. And we have protons that are positively charged and neutron, a neutral particle found in the nucleus. Now, let's think of it like this. Here is a simplified diagram of our nucleus here, our proton here, our neutron here, and our electron here. You can think of the nucleus kind of like a debate room, right? Here is our debate room, and we have our debaters here. And imagine you are in a debating room meeting your team members. And if they're good, they will be argumentative and as convincing as you are. And so when a lot of people have a lot of strong opinions, sometimes the group can have some tensions or people just leave and break away. And that's why we need our neutrons. Neutrons are kind of like that friend you have that keeps everyone together in the group. And it talks to everyone, it doesn't take sides, and just a nice friend to keep the group together. So without neutron, we wouldn't have this nice, dense nucleus here. Basically, the role of neutron is to say, hey, let's stay together and as a team. So what about this guy? Electrons kind of, they're kind of like social butterflies. They kind of, stay outside the room usually, and they may leave, join other debate teams, or they may stay. So just think of them as, social creatures that, create connections and relationships. So now we capture that neutrons are kind of like the glue to, bring people together, bring the protons together. And what does proton do? Well, imagine you signed up for the debate competition with a very weird rule. Like say if a team already have 3 members, your team must not have 3 members. You must have a unique number of teammates. And so this is what proton does. Proton kind of like defines the element. Imagine the element is just like when you sign up for the competition, your debate team needs a name. Do you have 1? is hydrogen, 6 carbon, and 7 nitrogen. I'll jump to the most related to neurobiology. 11 sodium, 17 chloride, 19 potassium, and 20 calcium. And the number of protons define the element. And here we have our periodic table. And you can see all of the numbers here, right? Here, here, here. And if you want to look further, this table is already here for you. And if you're nerdy enough, there's also a periodic table song. I find it quite exciting and motivating, actually, especially when, on the days when you're not feeling very productive. This will definitely bring you back to life. So we know that neutrons glue the team together, and protons carries positive charges and defines elements. And what are electrons doing? First, electrons carry electric charge. They are usually negative. And second is, if we look at here, we have our neutral sodium with 11 protons and 11 electrons. And the net charge is 0. And say one electron decide to leave and join another team. And now we have 10 negative charge and 11 positive charge, which means we have a positive sodium ion. And that is very important in our nervous system, in our neurons. If you look at module 1, you will see a lot of sodium ions. And another function of electron is it bonds. It bonds its social being. It likes to bond with other social beings. And so if you look at, say, water, hydrogen, and the molecule structure of water is actually they're sharing the electrons to form water. Without water, there's no life. Basically, we can say that without electrons, there's no life. Same with DNA. If we zoom deeper here, electrons are also shared between atoms here inside the sugar phosphate backbone. And without it, we can't have our DNA structure. And hence, I think it's fair to say that sharing is caring and is embedded in our DNA, is who we are. So we've learned things are made of matters, and matters are made of atoms. Atom has a thing called nucleus, and nucleus contains protons and neutrons. And the thing about protons is that they define identity. Different numbers of protons define different elements. And the thing for electron is that electrons create, wait for it, possibility. These social creatures, leaving, joining other team, sharing, will create ions and different molecules, and that's kind of made who we are. Coming up next, every atom contains positive and negative charges, yet our brain can generate electricity. How is that possible? Next time, we'll be looking into how does electricity exist?